Awesome. Good afternoon. Thanks everyone for coming out after lunch on Sunday. My name is Jason, and I'm an information security professional.
Hi, Jason.
Fantastic.
If it's red flashing, do you always have to say?
That would be helpful. Yeah, I'd appreciate that. I'd like to talk about a problem that I see with application security and how I think vulnerability management will fix it. I'll walk through a framework that I developed to sort of put together a program, how to set it up, some processes that are involved, how to measure the program once it's up and running, and then some tools that kind of do it on the cheap. First, a really quick thought experiment. Can I get everybody to stand up real quick? Awesome. If your birthday ends, or if your birthday is in an odd day, could you just put your hands together, kind of stretch them out a little bit? And if it's on an even day, kind of put your hands out parallel like that. Awesome. I can tell my mom that I got a standing ovation at DerbyCon. She'll love that. Thank you. All right. Now, what does a mature application security program look like? We have two really, really good models. The Software Assurance Maturity Model by OWASP kind of puts it together like this. They have 4 business functions. Under that are 3 different security practices, and then under those are a bunch of different security activities. And they lay those out in sort of varying levels of maturity. So the idea is you take what you're doing, you map it to this, and then you can see where maybe there are some holes, and then you can move your program maturity up a notch, right? Another one is the Building Security in Maturity model, which arranges it in very much the same way. You have 4 high-level business functions, some practices under that, and then a whole bunch of different activities. They went about it a slightly different way. What they did is they went to 65 different organizations and observed what they were actually doing. So this is what organizations are really doing. So if you compare what you're doing to this, you can sort of compare what you're doing to what other companies are doing. But what both of them come down to is a series of application security touchpoints. Right? This is where, when software is being written, the application team should work with the security team. When you're putting together requirements, let's build out some security requirements. When you're doing architecture, let's do some risk analysis. When you're writing code, let's do some security code reviews. And then before it's deployed, let's do a pen test. But then what happens after it's deployed and out there? Maybe if it's a PCI scoped application, you do a pen test once a year. And therein kind of lays the problem. When new attack techniques come up, you kind of got to test your applications against that new technique. And you don't always catch everything during the SDLC. What about those hosted applications or legacy applications? Maybe you have some COTS applications, right? There's always Bob from marketing who says, guys, we need the Twitters and the Facebook and a blog right now. And then he puts WordPress on AWS, and the security team is lucky to know about it, let alone be able to test it or apply patches to it later on. The Verizon data breach report may be the most overquoted report in InfoSec. But they looked at 1,000 different incidents over the past year, and they boiled it down to 9 different attack categories. And web application attacks is number 1, right? It has 35% of all of those different incidents. It calls web apps the punching bag of the internet. But we kind of already have a model for how to do it right. If you look at what the security team is doing with infrastructure, networks, and servers, they're scanning that stuff. They're doing assessments on a monthly or weekly basis. So what we need to do is apply that same rigor to our applications as well. This is actually a program that I've built where I work. We are continuously assessing over 200 internet-facing production applications all the time. We're doing it on a recurring basis, so we're always gaining findings and feedback from what's really out there. This is the framework that I put together, and I'll walk through this in a minute. But first, just a little bit of kind of background information. Our goal, the reason why we're doing all this to begin with, is we want to identify and reduce risk. Right? It's not about finding all the vulnerabilities and fixing them. If we just did that, we'd have our developers doing nothing but that and not working on new functionality and generating customers and revenue. We'd go out of business. On the bottom here, I have your basic sort of risk equation. To have a risk, risk is the probability that a threat will exploit a vulnerability and then kind of the business impact of that, right? So Anonymous is going to DOS our e-com site on Black Friday and we're going to lose $10 million. So you need vulnerabilities, assets, and threats. And if you can affect either one of those, you can essentially reduce risk. Now, it's a horrible idea to decrease the value of your assets. I don't recommend that. And I'm not going to go and hunt down Anonymous and tell them to stop DOSing our site. I just don't have the time. So vulnerability management is where we can affect the most change over our overall risk posture. This is how Gartner defines infrastructure vulnerability management. I'll kind of go through this quickly to set up the stage for applying that to web applications. First, you got to have policy. You have to define what your ideal state is. Then you go out, you find all your assets, you do your initial sort of vulnerability scan and get that list of issues. Then you prioritize them. You do your basic risk assessment. Vulnerability A is a little worse than vulnerability B, so we're going to look at A first. Maybe you do some shielding. We deploy an IPS rule and block it at the network layer. And then you start fixing things. And while you're fixing things, you keep an eye on patterns. Maybe we're doing a really good job at patching Windows OS, but a horrible job at patching Java. Our Java is all out of date, and we're very vulnerable there. You kind of got to keep an eye on your threats and your vulnerabilities, and then that entire cycle can inform policy. You can update it, tighten it up a little bit. And this is something that is recurring. You do this over and over and over again. All right, back to the framework. What do we need to get started? First, policy. Everything we do should be rooted in policy somehow. Policy has executive buy-off. Policy kind of informs the culture of our company. In this context, it gives us a couple of different things. One, it gives us the authority to do the assessments to begin with. If you go to an app owner and say, hey, I'm going to break your site, and they say no, you point the policy and say, but it says I have to. It also gives us remediation timeframes. If you find a SQL injection bug, that should be fixed in maybe a week. And if that's in policy, then you have a better chance of doing that. It also gives us sort of secure coding standards, right? You should have a document that shows developers how to do things correctly. So when you find an issue later, you can point to that and say, here's my remediation advice for fixing what's wrong. You need a web application inventory. You need to know what you have. If you don't know what you have, if you never find Bob's WordPress instance on AWS, you can't do anything about it. And we also need some tools. The primary tool is a dynamic application security testing tool. And what DAST tools do is you give it a URL and it spiders the application. It follows link after link, finds all the pages, finds all the inputs, and then after it has everything, it starts to fuzz those inputs. It throws some attack traffic at it. And then based on what it gets back, it can tell if the application is vulnerable to that or not. I have the Gartner Magic Quadrant up here as a resource. It's kind of hard to see. HP and IBM have kind of the 500-pound gorillas in this space. Veracode and White Hat have some compelling software as a service models that are worth checking out. Another really good resource if you're looking for a tool like this is sectoolmarket.com. This guy's compared about 65 tools, both commercial and open source, across a bunch of different characteristics like price or how accurate the SQL injection detection is. All right, now we want to build our inventory. Here, port scanning and DNS queries are your friend. And Nmap's a fantastic port scanner, right? You give it your internet-facing IP addresses, and then it tells you what web servers are listening out there. There are a couple of Nmap plugins that when it finds a web server, it takes a snapshot. So then if you have hundreds of applications, you then have a picture of what each one looks like, and it makes it a lot easier later on. A couple other sort of out-of-the-box methods, or not really. Just Google name. If you don't have a really good place to start, if you go through a couple pages of results and use PageRank to prioritize, you have a decent list of apps to look at. If you do a whois lookup on a domain name, what you get back is who registered that site. If you do a reverse lookup, go the other way around, you can give a site like eWhois an email address, and it gives you back all the domain names registered by that email address. So if you're looking, if you know that admin@company.com registered your main ecom site, then maybe you can use this to find some other things that were registered as well. There is a reconnaissance framework called ReconNG, which is fantastic. It's done for reconnaissance what Metasploit did for pen testing. It's kind of a modular framework that anybody can write and add to. And you can script and tie things together and kind of automate a lot of this stuff. The guy that wrote this did a presentation last year here at DerbyCon. So if you haven't heard of that, find that and check it out. It's good stuff. All right. So now we have our tools, and we know what web applications we have. And we want to start doing assessments. Here's my first process, and this is how I go about doing that enrollment. It starts out with, I know web application, right? I have my inventory. And I sit down with the application owner, and we walk over what's going on, what they can expect, what we're going to do. And I get some information from them. One, the URL. If the site requires authentication, I need some test credentials. We talk about the schedule, when we're going to scan your site. It's a good idea to get who the development team is, right? Know who those guys are, and also figure out what tools they use. After we have all that information and they know what's going on, I then do two things in parallel. I configure my tool, right? I put in the URL and the credentials and all that stuff in there. And it's a really important idea to get sort of formal buy-off. What I've done at my company is we leverage the formal change management process. So we have a process where every application has a set of owners and a few support groups, and before you change that app, those people need to buy off. So I leverage that for those formal approvals. But if it's kind of a CYA thing, if you knock over an app and those guys deny you exist, then you could be in some trouble. When you're configuring your scanner, you also need to take business logic into account. A good example here is an e-com checkout page. Before you can check out, you might need to add some things to your cart. And then you might need to supply some shipping information. And then you might need to provide some payment information. And then finally, you can hit the checkout button. A DAST tool that's doing spidering may not follow that path. All DAST tools have something to take this into consideration, whether it's sort of a click-through and replay or a script that you have to write. But you have to know your tool, and you have to have some decent knowledge of the application that you're looking at. All right, so we have permission. Our tool is configured, and we can finally start our scanning. We can finally start our assessment. That first time through, I keep a good watchful eye on it to make sure that there's no business impact. If there is, I go back to the beginning, and maybe we're scanning during a high impact time, right? I need to adjust the schedule. Or maybe there's some functionality that just doesn't work well with our tool, and we need to tweak some stuff there. But if it's successful, we now move that into a continuous assessment phase, right? We scan that on a recurring basis as just business as usual. All right, so now we have some applications enrolled, we're assessing them, and we're going to get back some findings. And at this point, it can be a little overwhelming because there's a lot to look over. But a basic process for that is you have your continuous assessment, you get back some findings. We sit down and we analyze every one of those. The last thing you want to do, especially early on in a program, is report some false positives on, because then nobody will listen to you after that. So we sit down, we do some manual testing. We take screenshots, and we make a report that allows anybody to easily reproduce what the issue is. We also do some basic risk analysis, and we throw things into 3 separate buckets. If it's a really low risk, we kind of set it aside. We'll monitor it, we'll watch it. Maybe the threat vectors will change and it'll be more risky later, but for now, let's not worry about it. We have our very critical bucket, which is, holy crap, it's on fire, let's do something right now. In which case we also have a bunch of web application firewalls deployed. So this is where the shielding comes in. Maybe we'll deploy a WAF rule. And maybe it's just some really dangerous functionality that we'll just disable until we can fix it. And then there's sort of the normal bucket that then everything goes through. Here, we take that report, those steps to reproduce the issue, and we log those into the application's defect tracking tool. Your development team is going to have a bunch of tools and processes that they're already using, and the more you can leverage those, as opposed to adding some new stuff that they don't know about, the more successful you'll be. So leverage their defect tracking tool if possible. Now at this point, you've kind of given it over. It's theirs. If they have any questions, they let us know. But at some point, somebody will let us know that it's closed, right? Maybe it's a phone call, maybe it's a notification from that defect tracking tool. At which point we manually retest it. If it's fixed, great, drink a beer. If not, we go back to the beginning and try again. Now this is kind of where things can go off the rails a little bit. So I'm going to sort of pause here and go over a couple of things that I think are really important for a web application vulnerability management program. One, these aren't cookie cutter patches. If you find something on a Windows box, right, maybe all you need to do is download a Windows patch, apply it, 5 minutes, you're done. In this case, your developers have to write a patch. That's going to be a software programming project all on its own. And when you're doing your risk assessment, you really have to kind of take that into consideration, right? There's some cost there that is involved that may not be involved in other things you're doing. Say you buy a nice new shiny grill, you got it in the backyard, you like steak, it costs $1,000, and you really want to keep it safe from neighborhood kids. You don't want it to get stolen or messed with. It doesn't make sense to build a $10,000 fence around your yard to protect a $1,000 asset. In this case, right, it doesn't make sense to spend $10,000 of development time to protect an asset that's only worth $1,000. So you have to think a little bit harder before you make people go off and do stuff. Another thing that I think is really important is it's easy and tempting to take a tool, scan a site, get this crazy 100-page PDF, and then email it off to the dev team, in which case they're going to ignore you, call you an idiot, and never talk to you again. This is why we leverage the defect tracking tool that they're already using if we can, and we take one bug and assign it to one person. This is a concept called bystander apathy. There's lots of cases where right, you're in a big crowd and you're being attacked or you're having some medical issue, and this big crowd all sees you, but nobody does anything about it, and then somebody dies. The way to fix that, if you're ever in a big crowd and you're having a heart attack, point to somebody and say, you, call 911. If you assign that responsibility to one person, you're much more likely to survive. And in this case, if you assign that vulnerability to one person, you're much more likely to get it fixed. I think I've already talked about most of that other stuff. All right, metrics. I said earlier that our entire goal is to identify and reduce risk. These tools can cost a lot of money, and application security specialists can cost a lot of money. So the executive team paying for that want to see that they're getting some value out of that. And the best way to do that is take measurements. Measure your risk this month. Measure it again next month. Do some trending. Show them what's really going on. I've seen a lot of bad metrics, so I want to talk for a couple of minutes about what a good metric looks like. Metrics are consistently measured. Week after week, the same data should come up with similar numbers. They're cheap to gather. If it takes you 2 days to crunch the numbers, chances are you're not going to do it enough to be effective. So automation is really key. Figure out how to do it, automate it. It should be expressed as a number or a percentage, right? The red light, green lights, those aren't metrics. Don't do that. It should be some unit of measure, right? Count of defects, number of hours, number of dollars. And it should be contextually specific. You should be able to look at it and make decisions based off of it, right? If an executive looks at it and doesn't know what they're looking at, has no idea, doesn't get any value, then you're wasting your time. Some good metrics in application security. Security testing coverage. I have 100 applications. I'm testing 50 of them. Vulnerabilities per application. Application A has 3 bugs. Application B has 30. We should probably spend more time looking at B. A company top 10 specific, like a company specific top 10 vulnerabilities, right? Whenever you're talking about developer training, usually people go to OWASP, they take the OWASP top 10 and they train developers how not to do those things. But it's a lot more useful if you know what your developers are doing wrong, right? You have that company specific top 10 list and you can train developers to not do things that they're actually making mistakes on, rather than some generic lists that, mean time to mitigate vulnerabilities, right? This measures 2 things. 1, how efficient, how effective is your team at fixing the issues? And 2, how long is something sitting out there? If a SQL injection bug is sitting out there for 3 or 4 months, that's a big risk, right? You might want to look at your process and speed those up a little bit. This is an example of a dashboard that I put together once a month and send it to all of the stakeholders. I have it's a count of vulnerabilities per risk criticality, and then I trend that out over 6 months. So you can see, hey, our highs are downward trending. We must be doing some good stuff. I have the top 10 vulnerable applications, and then top 10 company-specific vulnerabilities as well.
Your metrics are based on the same app over the month, or just off of different apps? So like your highs are all...
Oh yeah, that's the risk ratings are all of our applications. So all 200 plus, that's a count of everything. And then with the bottom two, I do some month-over-month trending. I don't know if you can see it. The Billboard has like a top 10 list, and then they say, hey, this song's gone up 3 spots this week, yay, or hey, this song's fallen off. Month-over-month, I find it very useful to, hey, this application has less vulnerabilities than it did last month. That application team is doing good. Let's give them an attaboy. Or hey, this application is new to our top 10 list. Maybe it's something that we recently enrolled that presents a large amount of risk to organization. We want to take a close look at that. All right, and finally, some tools to kind of either play with in a lab or try to put this together on the cheap. 2 really good but cheap DAST tools are Burp Suite and the OWASP that attack proxy. Burp Suite is free. It has a free version. It also has a pro version that's about $300, and it's a fantastic tool. I highly recommend dropping the cash on that. Zap is written by a good team. It's getting very good very quickly, so it's worth checking out as well. And it's open source. 2 really well-known and good defect tracking tools are Jira and Bugzilla. Bugzilla, free, open source. Jira, it's an application, like it's an enterprise tool that can get pricey. But if you want to pull it down and play with it, it's $10 for 10 users. There's this concept of a vulnerability aggregation tool, and a tool called ThreadFix by the Denim Group is a really good open source tool that does this. You can upload results from several different DAST scanners, and it does some correlation. It knows that this SQL injection bug found by 3 different tools is really the same bug, so let's just report on it once. It puts together some fancy graphs and does some metrics. And it also uses like Jira's API to automatically send those bugs to the development team's defect tracking system. So it automates some of the process and gives you some fancy metrics, and it's definitely worth checking out. And that's pretty much it. I made a Sans Gold paper where I covered the same stuff, and it's a 30-page, pretty in-depth document. So if you find this of value, that page goes into a lot more depth than I did here. The link down at the bottom, the bit.ly link, I threw my slides out there, and there's also a link to that paper. So if you're interested, go check that stuff out. And that's it. Thank you guys for coming. If you have any questions. Thank you. Anybody have questions? Sure.
So some of the things that web app scanners usually don't catch, like permission escalation and stuff like that. Are you doing any manual process to kind of add that into your vulnerabilities? Is anyone looking at it, or are you just more just doing dynamic scanning?
What we have, and what I had the benefit of starting with, is a pretty mature SDLC security team already. So we have a pretty solid product security team that's doing some good work before these things get out there, right? I'm just trying to look at the big picture and look at the production applications to capture everything in one spot. If you're looking for a place to start, like if you don't have that mature program, I think this is also a good place to start, because you can go to your executive team, do a scan of all your production applications and say, hey, look, these are the issues we have. We need to start looking at this earlier in the process and fixing things as soon as possible. So yeah, we're looking at sort of the bigger picture and issues that a DAST scanner might not catch. But that's another team. Sure.
So you had mentioned when you're looking at assets, you don't want to fix a particular asset if the value of fixing it is more than the value of the asset.
Mm-hmm.
But you also take into account the scope of reach from that asset. So a lot of times it can become a pivot point for an attack to get into another segment.
Sure.
So I'm just curious if your process takes that into account, and how do you quantify that?
Oh, definitely. Yeah, you should look at, we have a big asset tracking system, work for a big company, so we have the benefit of having some cool tools. The asset this big asset tracking system takes into account what kind of data is on the system, whether there's PII or credit card data, or where it's sitting on the network, right? Is it internet accessible? Is it internal? Is it on a network segment that's carved out, or is it somewhere inside that has a lot of reach? And we have a vulnerability aggregation tool that takes the output of our DAST tool and sort of correlates it with all that other data to come up with a very rich risk score. So yeah, we definitely take that stuff into consideration. And I mean, nobody wants a site out there that goes and gets defaced and makes your company look crappy. So you have to take stuff like that into account as well.
So how do you aggregate like the firewall rules, the different, I guess the different preventative controls that you have in place? How do you take, let's say, a particular high risk vulnerability and score it against what controls you have in place that protects it from being able to, let's say, be a pivot point back into another? Like, how do you reduce that quantitative risk score based on? I'm just curious how you guys are doing that. Is that a process that you have today? Do you have a tool that helps you do that? Or?
Yeah. Actually, we have a GRC team that has come up with this crazy, insane calculation. And I'd actually be happy to share that with you. So yeah, we can talk about that afterwards.
How large is your application security team?
The people doing this, we have like 1 FTE that's involved in this. So we're using one of those SaaS tools that do it in parallel very well. Our application security team, that sort of mature product security team, they're about 6 or 7 people deep. Cool. Well, hey, thanks a lot. I appreciate you guys.